Okay, we're going to start our Unit 6 end of unit review. Here in problem 1, we have a parabola with focus 3, 4, and directrix is the line y equals 2. And we're given that the point negative 1, 7 is on the parabola. And we want to select all of the statements that are true. So let's first just recall the form that our parabola has. So we have x minus 3 squared plus y minus 4 squared equals y minus 2 squared. And let's just check if the point 5, 4 satisfies this equation. So we have 5 minus 3 squared plus 4 minus 4 squared equals 4 minus 2 squared. And this simplifies to 4 equals 4. So 5, 4 does lie on the parabola. For part B, we're asked if the point negative 1, 7 is the same distance from the point 3, 4 as it is to the x-axis. Now, since we know that negative 1, 7 lies on the parabola, we know that this distance here from negative 1, 7 to 3, 4 is the same as the distance to the line y equals 2. So B can't possibly be true. In part C, we already worked out our equation of our parabola, and that is the right equation, so C is true. D represents a different parabola, so that one is false. E, we're going to do the same strategy as A. Let's just check the point 6.56, see if it satisfies our equation. So we have 6.5 minus 3 squared plus 6 minus 4 squared equal to 6 minus 2 squared. Here we get 3.5 squared plus 2 squared is equal to 4 squared. And 3.5 squared comes out to be 12.25. And so we get 16.25 equals 16, which is false. So the point 6.56 does not lie on the parabola. And for part F, it says if we have some point xy on our parabola, does the distance from xy to the point 3, 4 equal the distance from that point to the line y equals 2? And we know that since this is a parabola, this is a true statement. Okay, problem 2. We're given a line, M, represented by the equation y plus 3 is equal to negative 3 over 2 times x minus 4. And we want to select all the equations from the ones below that represent lines perpendicular to M. So, recall that given a line in point slope form, like the one we're given, this coefficient here is our slope. So our slope of M is negative 3/2. And to find the perpendicular slope to M, we take the negative reciprocal. So perpendicular slope, Euler slope, is positive 2/3. So we want to identify all the lines with slope positive 2/3. So notice for A, if we solve for y, we're going to get 4 minus 3x over negative 2. And if this simplifies, or when you simplify this, you're going to have slope negative 3 over negative 2, which is positive 3/2, which is not what we want. If you look at B, and you solve for y, you're going to get 6 minus 2x over 3, which can be worked out to, not 3, 3, but 2 minus 2/3 x, and our slope is negative 2/3, which has the right magnitude but the wrong sign, so b is not perpendicular to m. For the line C, solving for y gives us 8 minus 2x over negative 3, which can be simplified to negative 8/3 plus 2/3 x. And notice this line, line C, does have the right slope of positive 2/3, so C is perpendicular to M. For line D, it's already in point slope form. We can easily identify the slope to be 2/3, so D is perpendicular to M. E is also in point slope form, and we can see that the slope is negative 3/2, so E is not perpendicular to M. F is in point slope-intercept form, and we see the slope is the slope we want, positive 2/3, so F is perpendicular to M. And finally, G has slope 3/2, so is not perpendicular to M. So only C, D, and F are perpendicular to M. For question 3, we're given a circle with center negative 3, 4, and radius 13, and we want to select all the points that lie on the circle. So notice for the point in A, negative 3, 4 is the center, so that can't possibly lie on the circle. Let's test the point 10, 4. So let's recall the equation of the circle, which is x minus negative 3 squared plus y minus 4 squared is equal to the radius squared. And let's use this equation to test the points B, C, D, and E. So the point 10, 4, if we plug in 10, we get 13 squared plus 0 squared equals 13 squared, and that is certainly true. So B is on the circle. If we plug in 2, negative 8, we get 5 squared plus negative 8 minus 4 squared equals 13 squared. So this is 25 plus negative 8 minus 4 is negative 12 squared, which is 144. And 13 squared is 169. And now adding these together, you do get 169 is 169. So C also lies on our circle. Checking the points negative 3, negative 9 gives negative 3 plus 3 squared plus negative 9 minus 4 squared equals 13 squared. And here we end up with negative 13 squared equals 13 squared, which is true. So D also lies on our circle. And finally, negative 9, 16, we have negative 9 plus 3 squared plus 16 minus 4 squared is equal to 13 squared. Negative 9 plus 3 is negative 6. If you square that, 36. 16 minus 4 squared is 12 squared, so you get 144. And from our calculation over here in, what was that, part C, we know that 144 plus 25 is 169. So 144 plus 36 cannot possibly equal 169. So our point E does not lie on the circle. All right. For question 4, we want to find the center and radius of the circle who has this equation. So, isolating the whole number on the right side, we obtain x squared plus 10x plus y squared minus 16y is equal to 80. And now, looking at these first two terms and completing the square, we need a perfect trinomial. So we take the coefficient of x, which is 10, we divide it by 2, which is 5, and we square that to get 25. So we need to add 25 to both sides of our equation. And then a similar process for these two terms, taking negative 16, dividing it by 2, and squaring gives us negative 8 squared, which is 64. So adding 64 to both sides gives us keep wanting to write 18, 80 plus 25 plus 64. And now that we have these perfect square trinomials here, this can be written as x plus 5 squared plus y minus 8 squared is equal to 80 plus 25 plus 64, which is equal to 169, which, if we look up at the previous problem 3, in problem 3 we noted that 13 squared is equal to 169. So we can rewrite this as 13 squared. And now our equation is of standard form for the equation of a circle. So we know that the center is the point -5, +8, and the radius is 13.